Welcome to the Lawyers Talk Show on TASCTV, the voice of the Turkish American community. My name is attorney Erol Gülistan, and our guest today is engineer Atly Botas, who is Director, Business Development, Senior Project Manager at Americom Corporation. He is experienced in new business development and marketing, producing complete winning transportation project proposals, expressions of interest, fee proposals, qualification packages for the GSA, NJDOT, counties, municipalities, and other public transportation agencies. He's prepared and presented formal technical presentations to prospective clients, coordinated proposals with consultants, sub-consultants, emerging small business enterprises, and he's familiar with contract negotiations, contract structures, and development of project work scopes. On the technical side, he's developed management skills by combining design experience, construction-related experience, and inspection experience over a 32-year career. As a senior project manager, his technical experience ranges from bridge design, analysis, inspection, and new construction, and the rehabilitation of short and medium span bridges and other structures. His assignments have been in consulting engineering for the Department of Transportation of New Jersey, New York, Pennsylvania, Delaware, Connecticut, New Hampshire, and Florida, as well as numerous county departments of public works and public transportation agencies and large international private clients. He's also worked on numerous design projects, and he's inspected bridges and structures in multiple states, and he's familiar with all types and phases of inspections, from simple fixed steel, concrete, and timber structures to complex movable bridges, including swing span, bascule, and vertical lift bridges, as well as railroad bridges, toll plazas, piers, parking decks, buildings, and specialty structures. Thank you for being on the show today, Mr. Atly Botas, and welcome.
Good afternoon. It's my pleasure to be here.
Thank you for being on the show. And could you briefly tell our audience about yourself?
My name is Atly Botas. I was born and raised in the United States. All my education was in the United States. I progressed through the school system and got my bachelor's and master's degree at Stevens Institute of Technology in Hoboken, New Jersey. And I've been an engineer for more than 30 years at this point, closing in on 40 years, actually. And I enjoyed the journey. It's been a wonderful experience. I've worked with a lot of people, and right now I work more on the development of business on large projects, transportation projects in the Northeast region here.
Right. And tell us a little bit about your upbringing. What was it like, and where did you grow up here in the U.S.?
I grew up in Hawthorne, New Jersey. Actually, I started in Patterson, and we moved to Hawthorne, New Jersey when I was a little kid. So I spent almost 100% of my life in New Jersey. And my parents immigrated from Turkey in 1961, and 2 months later, I was born. And I have also two brothers and one sister, and one of the brothers is also a civil engineer, and my nephew is a mechanical engineer, and my daughter is a biomedical engineer.
Oh, so must run in the family. You guys have a lot of engineers.
4 engineers.
Mashallah. So, what was it like? I mean, what was it like growing up in America as a Turkish American?
We take great pride because years ago, there was not as many Turks in the United States as they are now. And when you saw a Turk on the street and you knew they were Turkish, there was not Turkish supermarkets or anything like that back then in the 60s. And when you saw a Turk, you felt warm, and you went over there, said hello, you exchanged phone numbers, and you visited each other. Today, you have so many Turks, you may not know quite a few of them that you see. Turks are everywhere. You have Turkish supermarkets and you have Turkish businesses. Back in the 60s and 70s, there was none of that. And I'm proud to say that I witnessed the development of starting the first Turkish supermarket here and for the whole community to grow.
Yes. And what sort of development have you seen in the Turkish American community growing up in the U.S. as a Turkish American? I mean, has there been any changes?
The first generation basically took jobs in factories, and they raised their kids to study and go to higher education. And that's what we were programmed with from an early age. We were told, study, 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 make something out of yourselves, make your life useful. Don't be a factory worker. That's what was impressed upon us on an early age. And that's what we tried to do. And what we did was we followed the orders, basically. There was nothing else. Today's society has so many different opportunities, so many different angles that could detract from your focus. Back then, there was no internet, there was no cell phones. So we basically studied and tried to make, get into better schools and to get decent professions. Today, you have an entire industry the Turkish population is into business and all kinds of businesses, whether it's from a market to engineering. There's engineering firms out there that are, run by Turks. And that's what we've seen it come to. And the future looks bright because now we're pushing our kids to go into even higher fields than we've achieved.
Yes. And I do see that progression happening in the Turkish American community. A lot more of the next generation is getting into a lot more of the white collar type fields, whereas the prior generations were more blue collar, if you will.
That's correct. That's correct. That's what I was alluding to. And like I said, our parents worked at factories, and they worked at minimum wage. They worked at stores, department stores. I remember the first generation back in the 60s. That's how they started out. And they worked long hours, multiple, shifts, including 6 and 7 days a week sometimes. And there were times when I didn't see my father because he's working a second job. And that's what they did. And for us to have this luxury of being able to study and to educate ourselves with their support and be pushed to higher levels, that's what we impress upon our kids. We want our kids to go higher than we've achieved.
Yes, and that's definitely a good goal. So I appreciate your input on that. Now, can you talk about a memorable or perhaps your most memorable moment that you've had in your career, or a memorable story that you can share about your career?
There's many, many experiences I've had, but the most memorable one happens to be some bridge designs that we made. Technological advancements in civil engineering, they don't want roads to be constructed over a long period of time. Likewise, the bridges, a small bridge typically takes 6 to 8 months to be constructed. So what we've done is we've used accelerated bridge technology, bridge construction technology, where a bridge is built in like a week, 7 to 10 days. And what I'm proud of is having been parts of 3 projects over an 8-year period where we built bridges that were built in 1 week. And that is a major accomplishment in the civil engineering industry right now. And I'm also proud to say that we won Project of the Year 3 times in 8 years. So that was quite a highlight. And we ended up going to, when I say we won it in the state of New Jersey. So we beat out all the other projects and consultants in the state. And we took it to the national level. And to see the people at the top of our profession was an honorable moment for me.
Well, congratulations. That's quite some accomplishments.
Thank you.
You're welcome. What advice would you like to give to students about the education process based on your experiences as an engineer? And perhaps a second question that's tied to this is what does it take to be successful in terms of being an engineer, in terms of the education requirements?
Well, being an engineer, you have to have a like of the sciences and mathematics. That's very crucial. If you're very good at math, if you're good at science, or if you have a good imagination of wanting to design something in the world, whether it's a better car or a better building, something that has a less of an impact on the environment, you should pursue your dreams. It's not far-fetched to think of, electric vehicles taking over gasoline-powered vehicles in the near future. So if you have any ideas, any of the young kids out there that have ideas that they want to create or invent, this is the field for you, basically. If you like science and math, you need to really, really work hard at that. Don't be dissuaded by the difficulty. If it wasn't difficult, everyone would be an engineer. But to get to an engineering level, you have to do a lot of math and science to prepare yourself in high school for college. This way, with good grades, you get into the better schools and get better degrees, and you start your career at a good level instead of working your way up from tedious work. It's better to come out and join the white collar force. We have those opportunities these days that our parents did not.
Yes. And in terms of education requirements, I know that your education experience, I believe you went to Stevens, if I recall correctly.
Yes, I did.
And that's one of the best in the country. But now about, in the career, because we have the education side to it, but then after the education is complete, we also have the going out into the field. What advice can you offer young engineers who are about to embark on a journey in their careers, about to take those first few steps or about taking those first few steps? What practical advice would you have for those young engineers who perhaps want to create, perhaps they want to innovate? What advice can you give them?
The best thing to do is before you graduate, say after your freshman year, if you're looking to go into an engineering field, there's many different fields in engineering. There's civil engineering, chemical engineering, industrial engineering, biomedical engineering. So there's many different areas out there. So if you're not sure which one to get into, try to apply for internship positions during the summers. Those are valuable experience. It can help determine whether you select the field that you like or whether this field's not good for you and you go a different direction in your second year. That's a good way to do it. This way you narrow it down to the field that you like and what you think it should be, and then you pursue that. In your second year, you could get an internship in the field that you like, and then you continue that until you graduate. And when you get out into the real world, what school doesn't really prepare you is the real world. In school, you learn a lot of theory. In the real world, it's the application of that theory. You want a practical application of theory. So what you're doing is you have employers that want you to do a project on time and under budget. That's the real world. They don't teach you that in school. And with that in mind, you've selected a good profession, the field that you like, and there's also different paths you can take within each career. Some people are okay with being an engineer for a long period of time, but there are other tracks where you can go into marketing and business development like I did, or you can go into management and go into executive level management. That's a different path. What happens then is you tend to get away from the technical aspect of it and go more into the business side of it. So there are a lot of paths within the career, but a good start is to build a fundamental base of technical knowledge and technical experience.
Yes. And thank you for that. How has COVID-19 affected your working conditions and business life?
During COVID, we worked from home remotely like everyone else did. Fortunately, we had switched to remote working capabilities back after Superstorm Sandy, and we worked from home. We worked pretty seamless. Our laptop is our network at work, so there is no difference no matter where you are in the world. As long as you have access to the internet, you can work, you could do your calculations, you could do your reports, you can design projects, you can work through Teams and WebEx. That's how we basically socialize from a distance and work together with the teams. You can have people in 10 different locations working on the same project at the same time. So it's a wonderful experience. We do miss the personal touch of seeing people face to face in the same room, but I think times have changed that. And now that we're dependent more on our laptops and the internet to do our work.
Do you think we're gonna ever go back to life the way it was before in terms of having meetings face to face and people meeting face to face, or do you think we're gonna stay in this virtual sort of world that we're kind of transitioning to? It seems like.
I think what's happening is we are transitioning right now. I think there will be fewer meetings in person. I think there will be more meetings on the web for the fact that there is no travel time. If you have to travel from the East Coast to the West Coast, you don't have to get onto a plane. You could do it virtually. So I think it's a trade-off. There will be some meetings opening up soon in person, whereas most of the travel, I think, just to save costs, companies will cut back on that and we will do it virtually. And another thing I want to say about the COVID times is construction work has not stopped. In fact, because of short lockdowns and people not being on the road, construction accelerated on the roads and bridges in my sector, in the transportation industry, including railroads. That's another area that I work in. They continued working, so while millions of people were out of work, the civil engineering industry was moving full speed ahead, and this is even before the new transportation bill is even passed in Washington.
Well, I know every industry was just about impacted one way or another from COVID, so that's good. Now, moving on, the pandemic has helped to highlight some of the unseen professions that have helped to make our health service work and show the positive impact that biomedical engineering and biological engineering in particular can have on people's lives. Biomedical engineering or medical engineering is the application of engineering principles and design concepts to medicine and biology for healthcare purposes, whether it's diagnostic or therapeutic. And biomedical engineering is also traditionally known as bioengineering, but this term has come to also refer to biological engineering. And the role of a biomedical engineer includes designing biomedical equipment and devices to aid the recovery or improve the health of individuals. And this can include internal devices such as stents or artificial organs, or external devices such as braces and supports, orthotics. It can also include creating and adapting medical equipment. It's a role that requires excellent knowledge of computing, biology, and engineering, and inventive nature, and good problem-solving skills. And even the COVID vaccine that we have is as a result of biological engineering by Dr. Öztrak'ın and Dr. Uğur Şahin, who are Turkish-German origin with the company BioNTech. So how useful will biomedical engineering and biological engineering be for the healthcare sector and for society?
Well, biomedical engineering is like a frontier right now. It is wide open. Think of it as life before the internet. When computers first came onto the scene, it was wide open. You could do a lot of things with computers. This is going back to the 1980s, before desktops, not even laptops, but desktops, before they came into the market. All throughout the 80s and 90s, it went from desktops, then to laptops, then to tablets. and the evolution of all the software that goes along with it, and including the internet. Now you see Google everything, basically. So the biomedical engineering is the new frontier for this century, basically. They have new applications that are just dreams right now. For example, my daughter talked about one project where they can take your DNA, for example, if you're a burn victim from a house fire or some catastrophic event, they can take your DNA, go to the laboratory and regenerate the cells and make new skin for you. Okay, that's impressive. Another area of biomedical engineering would be something like prosthetics, where you come up with new materials, whether it's something that replicates skin, something that is like not quite rubber or plastic, but somewhere between skin. It feels like skin. And then you got the motors, and you got biomechanical engineering in there where you develop motors and things for the limbs. So it's a wide open field, and imagination has no boundaries. So any of the younger generation that has any ideas for new products or new devices in the future, it's wide open to them.
Yes. And, you mentioned, some crucial aspects of it. I mean, even this artificial organ thing that people are now discussing, you have people who face all sorts of health ailments. You could have an individual who requires dialysis or a kidney transplant. And the current way the procedure is right now, if you pretty much have to get onto a list. And if you can't get a donor or find a donor, many times people, they get put into these difficult situations of not being able to find an organ donor. Biomedical engineering, it can eliminate the need to have that donor. So there may be an artificial organ that can be generated and then can be implanted into that person, curing that person's ailment or illness, and then allowing them to continue being a contributing member of society and a family member in their family. So it's very crucial, and I think this is, like you say, something that's wide open and at the very beginning. So it's going to be very interesting to see what comes of this.
Yeah, with kidney transplants, for example, you have a 5-year donor and the recipient waiting list. Okay, it could take 5 years, but now they have these small gadgets that they're designing that are getting smaller and smaller, where you could do dialysis at home. You don't even have to get to a urgent care center or some facility to do dialysis. So yes, every year something new is coming out into the market where they're developing, designing, and building these new devices, and it's a wide open frontier.
And that's exciting. I mean, you mentioned that idea and that product, and it's very exciting. Are there any other ideas in engineering and or technology, something you've seen recently that also excites you?
Well, the thing about it is I'm in the building professions, okay, construction. So you see new concretes that are stronger and tougher and blast resistant. You see higher steel grades, okay? You have 90 KSI steel. You're getting stronger materials out there. And for example, we talked about biomedical engineering. You got their ceramics, you got the rubber, you have different kinds of material on the smaller scale. So it's wide open in all the fields, I think. In mechanical engineering, everything is going down to size, okay? Today you have a motor that's, 2 foot long, and tomorrow that motor may be a nano motor, okay? They're talking about nano motors, implanting these motors inside people to scrape and clean their arteries. That's fascinating.
Wow. We've really come a long way, haven't we? I mean, come to think of, some of the most early examples of engineering, you have the wheel. And,
the wheel.
And here we've come. We've created the wheel. We've created engines, we've created the internet, and now we're creating nano robots that can clean people's arteries. I mean, go figure.
Is that something? There's companies out there, they have diagnostic tools where they can implant into you. It swims along in your bloodstream and it sends messages or signals back to a device that, monitors your condition. It's all fascinating. It's still, there's stuff out there now, but it's still being developed. It's wide open.
Wow. I mean, how important is science in the world we live in, Mr. Botas?
Science, you have to have a love for it. I mean, I've loved science since I was a little kid. And any kid that's out there, a young adult who loves science, take a look at what aspect that you like. Science is a big area. You have chemistry, you have physics, you have all the engineering sciences, like strength of materials, things of that nature. You have materials itself. So pick something that you like. You have to have an interest in it. And there's many, many areas where you have an interest. You look historically, for example, back in the 1700s, you have Galileo, you have the Newtons. They're coming down with the principles that were the foundations for engineering today. So the foundations are there. They haven't changed. It's the development of the ideas, the next generation of ideas. That's exciting. New materials, new thoughts, new processes. Sometimes they discover these by accident, like a certain medicine that started out for one potential, like, for example, the COVID vaccine. It started out as an anti-cancer drug where they take DNA and they take parts of the DNA out, flip them around, and put new code in there. And now, voila, they have a vaccine for COVID. So this is the exciting times that we live in.
It really is. Now, what do you think, in your opinion, is the most important engineering achievement in history that has benefited mankind?
Me personally, I'm biased. I have to go with building of cities. Okay, the Romans began with the aqueducts, the bridges. They came up with the arch. They came up with the domes. And then the subsequent generations after that, Mimar Sinan designed over 300 structures that were built during the Ottoman times. Okay, this was in the 1500s, where the Sultan Ahmet Mosque. It's a beautiful structure. I apologize for the background noise.
That's all right.
The mosque is a phenomenal structure. Even if you try to build that today, it would take a lot of time and a lot of effort. But to design it and to build it before the age of computers, that's a phenomenal task. Then comes along all the other developments of the industrial age. I apologize for that. Then comes the industrial age where the steam engine ruled and you had the development of rail cars and then eventually automobiles. That was all fascinating throughout history. But if there was any one thing that interested me the most, was building of cities back in the Roman times. That started it all, I believe.
Yeah. It's really fascinating how some of those structures are still around today. It just goes to show you the quality of some of those buildings and some of those structures, how they've been able to last the test of time. Like you said, the Sinan Mimar, he also had a lot of structures that have also stood the test of time. So that's very fascinating. Who do you think has contributed the most to engineering and sciences in history? Are there a name or a few names that come to mind when you think about the most contribution to engineering and sciences?
You had a lot of people over history. You can't, like a Copernicus, okay, the revolution of the daily rotation of the Earth around the sun. That's physics. Then you had Sir Isaac Newton with the law of motion. Okay, it's hard to pinpoint because there was a lot of contributions in each of the centuries. let's go to the beginning of the 1900s. You had Henry Ford with the automation of the automobile, and they had the assembly lines, and that employed millions of people. That's important to society. The assembly line is an invention in itself. The production of the machinery, that's an invention in itself. That employs a lot of different kinds, not just laborers, but engineers as well. There is not one thing I could pinpoint. It's just an evolution of many, many great innovators out there throughout history.
Yes, and there really are a lot of them. Even Einstein, you could throw onto that list, and Thomas Edison, you could probably throw onto the list. Nikola Tesla, a lot of good quality contributors to modern day society that we enjoy today. So we thank them for their contributions.
Absolutely, and today you can look at the new generation where they have different philosophies. You got the internet. It's a ton of information. What's exciting about our field, engineering, is, and in general knowledge, the amount of knowledge that is produced on a daily basis is the greatest that it's ever been in the history of mankind. And that's because of the computers and the computer age.
Well, how will artificial intelligence contribute to engineering? There's been some talk about AI potentially playing a role in engineering as well.
Well, AI has supposedly started out with trying to do the mundane, repetitive tasks so that a human is not required to take care of these mundane tasks. So the machine, the software, whatever it might be, learns how a human being would develop and proceed with the mundane tasks. It learns the mundane tasks, then it educates itself to produce and do more complicated tasks. That's the whole point behind AI, is to be able to acquire knowledge in the form of data and to apply that data into a way that it can predict the next moves, whatever the tasks might be.
Yes. Now, engineering has, changed. There's sometimes fields of engineering that become obsolete, and then there's new fields that emerge, like we just discussed, biomedical and biological engineering. Are there any fields that look like they're set to take off, and are there any fields that look like they may be obsolete or no longer going to be needed in the near term or distant term future?
Well, I don't think it's engineering fields are going to be obsolete. I think it's the mundane jobs. For example, toll collectors on toll roads. There used to be thousands of toll collectors across the country. That has been replaced by Easy Pass. So it's not the engineering that was obsolete. The engineering was still there to invent the Easy Pass and the systems that are used in Easy Pass. What became obsolete is the job of a toll collector, for example. Likewise, for a cleaner, cleaners can be programmed by, say, robots or something like that. And a robot doesn't have to look like a human being. A robot can be just any machine that can do a mundane task like cleaning bathrooms or cleaning houses or something like that. Like the robo vacuums, okay? They supposedly, there's engineering to create the robo vacuum. There's engineering, mechanical engineering, electrical engineering. But then you didn't take a job away, basically. It just made a person's life easier. It made vacuuming carpets obsolete, if you will. But the engineering was still there. So I don't think the engineering fields are being obsolete. They have to evolve. So one of the evolutions is working remotely, okay? Instead of being face-to-face at meetings and having that requirement, we are now digital. We don't need to print out papers on plans, for example. We do drawings. Instead of freehand drawings, we do it on the computer. We use AutoCAD, MicroStation to draft plans. So the office is paperless at this point. And Did it become obsolete? Drafters became obsolete, but those that learned MicroStation and AutoCAD are now doing the drawings on the computer. So it's not really an obsolescence, it's adaptation to newer technologies, basically.
Yes, and that definitely makes sense. So switching gears, and this kind of segues into the next topic. In 1960, Gümüş Motor Company became the first engine manufacturer in Turkey. And now Turkey's TAG group, or TOGG group, is set to mass produce electric automobiles in Turkey within the next 1 to 2 years. This marks an incredible achievement. When will electric automobiles overtake gasoline, diesel-run automobiles in society? Any predictions?
From all the things I've read about this, there are car manufacturers out there that, like Tesla, produced over 500,000 last year. They're going to produce well over 500,000 this year. You have other manufacturers coming online almost by the month. That with the number of cars being produced, I predict that by mid-30s, there will be more electric vehicles on the road than gasoline and diesel vehicles, because that's the goal of most countries, the United States with the Biden administration, as well as the EU and the Scandinavian countries. A lot of countries are going towards either 50% reduction, or the more like the Scandinavian countries, they were talking about 0% emission. So I'm looking forward to that. That should be exciting times.
Yes. You know, one of the challenges that have been highlighted are that there are not enough charging stations if you want to go from a set point A to a set point B for electric cars. So that's kind of been one of the major, I guess, aspects of electric cars that make people question, you know, is it the right time? Do we have the infrastructure? But I guess you're right. There's a lot of incentives and planning going on in this regard.
I follow the stock market, and I follow a lot of companies within the stock market on these new technologies. And there's companies out there that are about to take off in terms of number of charging stations, for example. In China, they're looking to have 50,000 charging stations in place within the next 5 years. The European Union, they're looking for an advancement of the number of charging stations. In the United States, I think it's roughly 1,000 stations right now, and that number is going to go up exponentially. It's not going to be incrementally, it's going to be exponentially that the number of charging stations are going to be increased. And don't forget, it's not only about electric vehicles. There's other technologies out there too. There's talk of hydrogen cells for cars, okay? So they're talking about hydrogen stations. They're experimental right now, but they're looking to make all buses, for example, either liquid natural gas or hydrogen cells, okay? So there's different technologies out there that are racing to be the leader in the market. So it's just a matter of, you know, think back to when the videotapes came out. You had the Betamax and you had the VHS. The Betamax went obsolete. Everyone went to VHS. So right now the competition is to be that new VHS and be the adopted system that is used widely throughout the world.
Yes. And when you say VHS, it just makes me wonder what the future has in store for technology. Because I remember VHS was the standard at one point, and now it's so obsolete that many people don't even know what VHS is, which was, you know, before there were DVDs and, you know, movie streaming and all that. So,
well, you remember how quickly the Betamax went away, and that's what it is today. Tesla's out there. Tesla has a big market share, okay? But you have all the other Chinese companies, and you have the Turkish company that's coming out with vehicles. Who knows? Maybe they'll be the market leader in a few years down the road.
You never know. You never know. And that's the fluidity of the world we live in. Things can change at a very fast pace. And that ties into the next topic. Baykar Defense produces the Bayraktar TB2 unmanned aerial vehicle, which has considered a game changer in terms of military drones that are utilizing technology such as automatic takeoff and landing. Now, recently, U.S. generals have been briefed on what was learned from hours of poring over footage from the Nagorno-Karabakh fight, where Turkey's globally lauded drones played a decisive role. How important are unmanned technologies in today's world?
Well, they're very important because it takes the soldiers out of harm's way, basically. It does jobs where a human being is not going to be impacted, okay? It's not going to harm our soldiers. Technology always gets applied to military purposes first before it trickles into the public mainstream. For example, we use a lot of drones here for land survey purposes, okay? For inspection purposes, inspection of construction sites. So the whole point being is when you have these drones, you're taking people out of potentially dangerous situations, okay? I think that's the biggest help. It's like doing the dirty job with using a machinery, basically, without harming humans.
Yes. And there's also, in addition to taking out the risk to human life, there's also the aspect of it making things more efficient. You know, when you operate, for example, a drone, the cost can be significantly less, I guess, perhaps as a result of taking out the risk, but also there's different components and different aspects of it. Now, changing gears, we have two questions left here before we conclude the show. How can people with vastly different cultural backgrounds live together peacefully?
Respect. I believe everything comes down to respect. If you respect your neighbors, regardless of where they came from, who they are, whatever their gender is, I think it makes for a peaceful environment. That's what it comes down to. You have to be treated the way you want to be treated. Okay, you have to treat others the same way. It's the golden rule, basically. It's fundamental, but some people don't get it. And the other thing is, I think society takes itself a bit too seriously sometimes. If we relax and listen to each other, that's the second aspect, is to listen. The part of respect is listening to others, see what they're thinking, instead of jumping to conclusions and without understanding the other person's viewpoint. One thing I learned during COVID is to empathize. You hear the news, you hear negative news all throughout the world, okay, about COVID, the dark clouds that was hanging over us during 2020. The thing I learned about is to empathize with people, to understand, to see if I can put myself into their shoes, to see how they're going through, what they're going through. There's millions of people unemployed. There's millions of people that lost their lives or they were sick. To understand what that means and to respect that, okay? The news does a good job of getting the news to you, but sometimes news is done for ratings. I think people should pay attention to and try to understand what other people are going through and what they're living through. And then maybe we'll have better respect for them. And I think it'll be a better society.
Yes. Now, how do we create a better world for the next generation? How do we leave it better than we found it?
To do our parts. We're not going to make it a perfect world by the end of our generation. Each generation contributes incrementally to the whole picture. If we were to take it from step one to step two, like, for example, with the new initiatives that are coming out for the environmental, setting goals for reducing emissions and things like that, you're hoping to have cleaner air for the next generation. By lessening pollution in water, you're keeping the drinking supply safe for the next generation. So air and water are covered. Same thing with schools and education. If we were to make it easily accessible for our bright students to get into good schools and to get better paying jobs, I think that's what we have to do. It's all incremental. And if we think of in terms of building a better society with each generation, we will go a long way to make it better for next generations.
Thank you so much. And thank you for joining us on the show today, sir.
It's my pleasure. I'm happy to do it. And I look forward to seeing you again in real time, in person.
Yes, sir. I do as well. And before we conclude the show today, engineering turns science and technology into something tangible and useful to society, finding solutions to real world problems. Engineering affects all aspects of life, and along with a respect for rule of law, is part of a solid foundation for great society. I ask our audience to consider the powerful and famous Turkish proverb, drop by drop, it becomes a lake. Thank you for watching the show, and see you next time.